Figure 20.8, Iterator types supported by each standard library container. In the left-hand column of this table, we show you the different containers from the standard template library. In the first two sections, we have the sequence and associative containers, and together they make up the so-called first-class containers, that is, the fully functioning containers. And then we have the container adapters, and container adapters, remember, are special classes that adapt the sequence containers to work like stacks, queues, or priority queues, respectively. Now, you'll notice for the container adapters that they do not support iterators, and one of the reasons for that is you're not allowed to just walk your way along a stack and do stuff with the different elements within the stack. You can only operate on one end of a stack to place items into the stack and take items out. Similarly, the concept of a queue requires you to place items into the queue at one end and remove them from the other. So you're not allowed to just walk through the underlying container's contents using iterators. On the other hand, the first class containers each support certain types of iterators. In the case of vectors and deques, we have or decs, some people pronounce this as dec. In the case of those two containers, we have random access iterator support. And vectors and deques or decs are basically implemented underneath the hood as array data structures. And just like a regular array, you can use a square brackets operator to access randomly any element within the container that you need to. The list class, on the other hand, supports only bidirectional iterators. So you can't just say, I want to go to element number 7 within a list. You can walk the list in the forward or backwards direction to get to any element within the list, which is what a bidirectional iterator supports. And similarly, all of the associative containers also support bidirectional iterators. And this table can be very handy when you're looking at various standard template library algorithms, that is, functions that perform tasks on these containers, because each algorithm has a minimum required type of iterator in order to be used with the given algorithm. So for algorithms that require random access iterators, I can only use them on vectors and decs. On the other hand, for algorithms that require bidirectional iterators, I can use them on the list class and also on all of the associative container classes. If a particular algorithm says it only requires an output iterator, then it can be used on all of these different types of containers. So based on the given algorithm you happen to be looking at, you'll see what the requirements are for the iterators to be used with that algorithm, and then you'll be able to figure out by looking at this table whether or not a given container can work with that algorithm. And if you still are unsure by looking at this table, remember that if an algorithm says it requires a forward iterator, then any forward iterator or more powerful iterator can work with the algorithm. So if something says it requires a forward iterator, if we go back to our hierarchy of iterators here, anything that is a forward iterator, a bidirectional iterator, or a random access iterator can be used with an algorithm that only expects forward iterators.